Okay, so today we are starting our trig proofs, and today we're starting with the basic 8 trig identities. And you see 6 on the screen, but it's actually disguised as 8, and I'll show you what I mean here in just a moment. So, sine of theta, what's the reciprocal for sine? Cosecant. So sine of theta could be written as 1 over cosecant of theta. And cosecant of theta is the reciprocal for sine, so we can write it as 1 over sine of theta. So there's the first 2. Those are also called reciprocal identities. Now cosine, what is the reciprocal for cosine? Secant. So instead of cosine of theta, I could write this as 1 over secant of theta. And instead of secant of theta, I could write it as 1 over cosine of theta. And tangent. What is the reciprocal for tangent? Using the same pattern I've been doing here. 1 over cotangent of theta. And instead of cotangent of theta, this would be 1 over tangent of theta. So there's 6 out of the 8. And here makes up 7 and 8. And we use this with the unit circle when we were trying to find tangent and cotangent, and that was tangent is sine over what? Cosine. And cotangent is which one? Cosine over sine. So on your handout, if you see anything that says the basic 8 or the big 8, these are the 8 identities that they are referring to. And we'll be using these today and throughout Unit 7. Okay, now we have a triangle. Oops, wrong button. And we are going to derive what's called the Pythagorean identity. This is probably the most common one that we'll use today and throughout this entire unit. So here is our angle theta. The side opposite of theta is the what? Where they have it labeled at? Sine, and the side adjacent is called the cosine. So we are going to derive what's called the Pythagorean identity. And it's called the Pythagorean identity because it's derived using the Pythagorean theorem, which is a squared plus b squared equals c squared. So a and b are the 2 legs, and the 2 legs are labeled sine of theta and cosine of theta. So if I start with sine of theta, so sine of theta is our side A, and sine of theta needs to be squared. Now when we write these, we always put the square in front of the angle. Now most of the time they'll use theta, they may use x, they may use a capital A, they could use anything really for that angle. So the square always goes in front of the angle. The other leg is labeled as cosine, and it needs to be squared. So I write that as cosine squared of theta is equal to c squared would be 1 squared. And what is 1 squared? 1. So that Pythagorean identity is just sine squared of theta plus cosine squared of theta is equal to 1. You need to memorize that. Sine squared plus cosine squared equals 1. Now, from the Pythagorean identity, we can derive other versions of the Pythagorean identity. So, starting with that Pythagorean identity, I'm just going to use sine squared plus cosine squared equals 1. I'm going to drop off the angle theta. Now, I could divide all 3 of these by sine squared. And simplifying that, sine squared divided by sine squared is 1. Cosine squared divided by sine squared is If I go back to the big 8, cosine over sine is cotangent. If I have cosine squared over sine squared, that would be what? Cotangent squared. And 1 over sine squared, I go back to these identities, 1 over sine squared would be what? Cosecant squared. So there's another version of the Pythagorean identity. Now this one you don't have to memorize because you can derive it from the original Pythagorean identity. And we'll come up with 3 more so you can kind of see a pattern. Now we're going to take the Pythagorean identity, sine squared plus cosine squared equals 1. Now in this last example I divided everything by sine squared. Let's see what we get when we divide everything by cosine squared. So sine squared divided by cosine squared is tangent squared. Cosine squared divided by cosine squared is 1. And 1 over cosine squared would be secant squared. So there's another version. Let's see. 2 more. Sine squared plus cosine squared equals 1. What if I want to get sine squared by itself? What would I have to do? Subtract cosine squared to both sides. So that gives me sine squared equals 1 minus cosine squared. So there's another version. And we'll have one final one. Sine squared plus cosine squared equals 1. On the last one we got sine squared by itself. Let's get cosine squared by itself. So in order to get cosine squared by itself, what would we have to do? Subtract sine squared to both sides. So that gives us cosine squared equals 1 minus sine squared. So that gives us 4 versions of the Pythagorean identity plus the original version. Now you only have to memorize the original version, which is sine squared plus cosine squared equals 1. And from that one, you can get all 4 of those plus more. So I could keep doing this, but we're just going to stop there and see if we can notice a pattern. So looking at the 3 I have on the screen, what do you notice is in common with these? What do they all have? They all have a 1. What else?
A square.
Yeah, they both have a square, and a square. So when you are solving these trig proofs, what you need to do is you need to look to see if you see a 1 with a squared trig function. So if you see a 1 with a squared trig, whether it's sine, cosine, tangent, or the reciprocal, then it's probably going to be a Pythagorean identity. So that's something you need to be looking for when you're solving these problems. Look for a 1 paired with a squared trig function, sine, cosine, tangent, or the reciprocal. Okay, so again, you only have to memorize the original one, sine squared plus cosine squared equals 1. Okay, first example. It says simplify each expression to a single term. So your answer should have only 1 term in it. So if you have a binomial, keep going. If you have a trinomial, keep going. If you have a polynomial, keep going. So problem number 1, we have a binomial times a binomial. So multiply those binomials by double distributing or FOIL. So distribute the sine of theta. So sine of theta times sine of theta would be sine squared of theta. So make sure the square goes in front of the angle. So sine times sine is sine squared. Multiplying again, sine of theta times 1 is sine of theta. Distribute the negative 1. Negative 1 times sine of theta is minus sine of theta. And one more time, negative 1 times positive 1.
Minus 1.
Yeah, minus 1. Notice I have 4 terms, so I need to get my answer down to a single term. So combining like terms, what happens? Those cancel. So this is just sine squared of theta minus 1. Now I've got all the math I can do at this point, but do I have only one term in my answer? No, so that means I need to keep going. So notice I have a 1 and I have a squared trig function. So if you have a 1 with a squared trig function,
Chicken egg. A lot better than you.
thank you. Okay, so if you see a 1 with a squared trig function, then it's probably a Pythagorean identity. So I'm going to do some scratch work over here. Instead of writing out SIN for sine and COS for cosine, I'm going to abbreviate this. So my shorthand notation is going to be sine squared plus cosine squared equals 1. So S squared plus C squared equals 1. Now notice over here I have sine squared minus 1. So over here I need to rearrange this equation so I have sine squared minus 1. So the first thing we need to do is subtract 1 to both sides. So that gives me sine squared minus 1 plus cosine squared equals 0. Now, the only thing I want to have is sine squared minus 1. So here it is right here. So how do I get rid of the plus cosine squared? Subtract cosine squared to both sides. So that gives us sine squared minus 1 equals negative cosine squared. Now, over here, instead of sine squared of theta minus 1, what is sine squared minus 1 equal to? Negative cosine squared. So that is my answer. Negative cosine squared of theta. So make sure you have that angle theta. So now my answer is down to only one term. Number 2, we are also double distributing. So distribute the cosecant of A. So this time, notice instead of theta, we have angle A. So cosecant times cosecant would be cosecant squared of angle A. Cosecant of A times 1. Cosecant of A. Distribute the negative 1. Would be negative cosecant of A. And negative 1 times positive 1. Negative 1. Now I know I'm not finished because I have 4 terms. How many terms did I have in my answer? How many terms did I have in my answer? Only 1. What happens with these 2 terms in the middle? They cancel. So bring down the cosecant squared of A and the minus 1. Now notice I have a 1 and I have a squared trig function. So it's probably a Pythagorean identity. So I'm going to do my scratch work over here. Sine squared plus cosine squared equals 1. Now if I have a cosecant squared, what would I have to do to get a cosecant squared? And we would have to have a 1 over sine, but since it's squared, we'd have to have 1 over sine squared. So in order to have a 1 over sine squared, I have to divide all 3 of these by sine squared. So sine squared divided by sine squared is 1. Cosine squared divided by sine squared is cotangent squared. Cotangent squared. And 1 over sine squared is cosecant squared. Cosecant squared. But I want cosecant squared minus 1. So what do I have to do next? Subtract 1 to both sides. So that gives me cotangent squared is equal to cosecant squared minus 1. So instead of cosecant squared minus 1, what do I put? Cotangent squared of angle A. So make sure you have the angle A after the square. So square first, then the angle. Next one, number 3. Here, before I distribute, what do you notice in the parentheses? What do you notice in the parentheses? Try to save yourself some work. There's a 1 and there is a trig function that is squared. So it's probably what? A Pythagorean identity. So over here, my scratch work. Sine squared plus cosine squared equals 1. And the parentheses, I have 1 minus cosine squared. So what would I have to do to that identity? If I want 1 minus cosine squared, what do I have to do to that equation? Subtract cosine squared to both sides. So that gives me sine squared equals 1 minus cosine squared. So I'm going to bring down the cosecant squared of x, and instead of 1 minus cosine squared, what could I replace that with? Sine squared of x. Is my answer down to only one term? No. So rule number 1, look for a 1, look for a squared trig function. Rule number 2, change things to sines and cosines. So if you have a cosecant squared, I want to write that with a cosine or a sine in it. So instead of cosecant squared, how could I rewrite that? 1 over sine squared of x times sine squared of x. What's the answer? 1. I'm down to 1 term. That's the answer. Next one, number 4. Let's see if I can see a shortcut. First of all, do you see a 1 and a squared trig? No, so that won't work. So if that doesn't work, you could change everything to sines and cosines. So let's go ahead and distribute first, and then we'll do that next. So when I distribute, sine times cosecant is going to be sine of x, cosecant of x, and sine of x times negative sine of x would be negative sine squared of x. And now we don't have a 1 paired with a squared trig function. So if you don't have a Pythagorean identity, change everything to sines and cosines. So the sine is good, but instead of cosecant, what could I rewrite cosecant as? 1 over sine minus sine squared of x. And what happens with these signs right here? They cancel, so this is just 1 minus sine squared of x. Now what does that look like? It looks like one of those Pythagorean identities because it has a 1 with a squared trig. So sine squared plus cosine squared equals 1. If I want 1 minus sine squared, what do I have to do to this equation over here? Subtract sine squared. And that gives me cosine squared equals 1 minus sine squared. So what's our answer? Cosine squared of x. Now I'm down to 1 term, so that's the answer. Okay, now number 5. We're going to make it just a little bit more longer. We're adding in another binomial that needs to be squared. So we are going to do our shortcut we learned back in Algebra 1. And when you are squaring a binomial, you square the first term. If I square the first term, that gives me a squared. Multiply these and then double it, so a times b is ab. And when I double that, that gives me 2ab. And square the last term, that gives me b squared. Now for the second binomial, we have a minus, and the formula is still pretty similar. Same pattern. Square the first term, what does that give me? a squared, multiply these and double it, that gives me minus 2ab. Square the last term, that gives me b squared. So those are the two shortcuts we're going to use. So for number 5, square the first term, what does that give me? Sine squared of x. Multiply these, what do you get? Sine x, cosine x, and double that, it gives us 2 sine of x, cosine of x. Square the last term, and cosine, when you square it, gives you cosine squared of x. So that's the answer for the first binomial. Now, squaring that second binomial. So we have a plus sign between the two. Now, squaring the first term, what do you get? Sine squared of x. Multiply these and double it, what does that give me? Yeah, minus 2 sine of x, cosine of x. Squaring the last term, what does that give us? Positive cosine squared of x. Now the instruction says to get your answer to a single term. Is that a single term? No, so we need to do a little bit of combining like terms. What like terms would you like to combine first? I don't want to do that. And I'll show you why in just a second. Now here, Rita did say 2 sine x, cosine x, and this one over here makes what? 0. So we have the 0 pair right there. So those go away. Now I'm going to break down what we have left over. What we have left over is sine squared of x plus cosine squared of x plus sine squared of x plus cosine squared of x. Now, why did I not want to combine these two sine squares? Read it to yourself.
Would be sine squared 2x?
Read it from left to right. What does this say? What does this say?
Sine squared.
Everybody out loud. What is this? Sine squared plus cosine squared. What does that equal? 1, right? That was called what? Starts with a P. Pythagorean identity. You're supposed to be memorizing, right? Sine squared plus cosine squared equals 1. And over here, sine squared plus cosine squared equals 1. So we are just legitimately adding 1 plus 1, and our answer is 2. Is my answer a single term? Yes. Yes, it is. Okay, next example. Now, this example, really, we're not doing this one because this one was not so it's not here the way it's intended to be here. The only thing I do want you to write down here is to make yourself a note that you can factor trig identity. And we'll be using this later. But I do want you to factor this as a perfect square trinomial. So when we are factoring perfect square trinomials, put your parentheses with a square. And how do we figure out the binomial that goes inside? You take the first term, square root it. So the square root of sine squared would be sine. Don't forget the theta. And square root of the last term, square root of 1 is 1. And keep the sign for the middle term, so this would be a plus. So that was the only thing I wanted you to see in that problem, is that you can factor trig. And we'll be doing that when we are solving trig equations later on. Okay, moving on to the next section. The instructions say to simplify the left side to equal the right side. Now, throughout the unit, you may see instructions that only say to verify. So if you see instructions that say verify, this is what you are doing. You are showing that the left side equals the right side. So you're starting with one side, you're doing work to that expression to show that it's equivalent to what's on the right side. And this is what's called a trig proof. Now, it's not going to be like geometry where you have to write out the explanation of why you can do it. So you're not actually writing out reasons why. We're just doing some math. So we're doing kind of like half of a geometry proof. We're just doing the work. We're not showing the definition side of it. So we're going to start with the left side. So the left side is the equal sign. We have tangent of x divided by sine of x. So starting with the left side, I need to do work with the left side so that I can prove that this equals what's on the right side, which is secant of x. So I need to do some scratch work over here so that I can find that it does equal secant of x. Now, when we were doing these original, 136? Yeah, problems 136. One of the first things I mentioned is you need to look for a 1 paired with what?
Square.
A squared trig. So looking at tan of x over sine of x, do you see a 1 paired with a squared trig? No. So it's not a Pythagorean identity. What is something else I told you to look for? Or what is something else I told you to do? Change everything to terms of sine and cosine. So for tangent, I can change that to what? Sine of x over cosine of x. And that was one of our big 8 identities. You need to memorize those. So tangent is sine over cosine. Now the denominator is good. We already have sine of x. But I'm going to make this sine of x over 1. And we are going to divide those. So I would have sine of x over cosine of x. And instead of dividing by sine of x over 1, what could I do? Multiply by 1 over sine of x. What happened? Sine of x in the numerator, sine of x in the denominator, they're a factor of 1. We no longer have them. And what's left for the numerator? In the numerator, 1. What's left in the denominator? Cosine of x. Now, what was our end goal? Secant of x. Well, what is 1 over cosine of x? Secant of x. We're finished. We started with the left side, so we started with tan of x over sine of x, and we show that it does equal secant of x. So start with the left side, do operations to that expression so that it equals the expression on the right side. Number 8, we have, starting with the left side, cosine squared of x minus sine squared of x. So we are starting with the left side to show that it equals the right side. Starting with the left side to show that it equals the right side. Now, one of the things I mentioned, you need to see if you have a 1 paired with a squared trig. Do you have a 1 paired with a squared trig?
Yes.
Do you see a 1 on the left side? No, not on the left side. So that won't help us this time. Next thing I told you to do, what else did I tell you to do? Change everything to sine and cosine, but it's already done, right? So here's the third thing third hint I can give you. And that would be to look at your answer. So looking at my answer is 1 minus 2 sine squared. Well, looking at my original left side, do you even see a cosine squared in the answer over here? No. So I need to do something to cosine squared to somehow convert it to a sine squared. How could I do that? Pythagorean identity. Sine squared plus cosine squared equals 1. I want to get rid of the cosine squared. So get cosine squared by itself. How would I get cosine squared by itself?
Add sin squared x to both sides.
This is positive, so I need to subtract sine squared to both sides. So that gives me cosine squared equals 1 minus sine squared. So over here, instead of cosine squared, I can replace that with what? 1 minus sine squared of x minus sine squared of x. So instead of cosine squared, I changed it to 1 minus sine squared. What should I do next?
Add sin squared x to both sides.
Look at your answer. Combine my like terms, right? So bring down the 1 and negative sine squared, add those together, we have negative 2 sine squared of x. So I started with the left side, and I have now proven that it equals the right side. So it's a puzzle. You have to figure out the puzzle. Most of the time, it's kind of fun until you get stuck and don't know where to go. So if you get stuck, remember the tips I've been telling you. Look for a 1 with a trig square. Change everything to sines and cosines. Look at the answer. See if that gives you some inspiration. So looking at number 9, we have cosine of x minus 1 over sine of x. Now thinking about my trig, do we have a 1 with a square trig? No. Next trick. Change everything to sine and cosine. Does that trick help me? The last tip I can give you is to look at the answer. Well, if you look at the answer, how many terms does it have? 2. So I need to break this up so that it's broken into 2 terms. So what I'm going to do, I'm going to take both terms in the numerator, divide them by what's in the denominator. So cosine of x divided by sine of x. Negative 1 divided by sine of x. So this would be cosine of x over sine of x, and we'll have a minus between the terms, and then the 1 needs to be divided by sine of x. So everything in the numerator was divided by sine of x. And what's cosine of x divided by sine of x? Cotangent of x. And 1 over sine of x is equal to cosecant of x. So we just proved that the left side equals the right side. One more. Number 10. Number 10, we have sine of x over cosine squared of x minus 1. Think about all the tools and tricks. What should you be thinking first? Pythagorean identity, because you have a 1 with a cosine squared. So let me do some scratch work over here. Sine squared plus cosine squared equals 1. I want to have a cosine squared minus 1, so I'm going to subtract 1 to both sides. So sine squared plus cosine squared minus 1 equals 0. And I want just cosine squared minus 1. So what should I do next? Subtract sine squared. So that gives me cosine squared minus 1 equals negative sine squared. So for the numerator, it stays the same, but instead of cosine squared minus 1, what should I put? Negative sine squared of x. Now do those cancel? In the denominator, this is sine squared, and the numerator, this is sine to what power? The first power. So are those equal degrees? No. So that means only 1 in the numerator will cancel with only 1 in the denominator. So instead of having sine squared in the denominator, it's knocked down 1 degree. So now it's just sine of x. So what's left in the numerator? a 1. What's left in the denominator? Negative sign of x. And 1 over negative sign of x is equal to negative what? Cosecant of x. So we just proved that the left side equals the right side.